In this video, we are given a system of equations a plus ab plus b is equal to 41, a squared plus b squared is equal to 61, and we have to solve for the value of a plus b, in which a and b are both integers. Please don't forget to like this video and subscribe to my channel, and let's get started with the solution. Let's designate a plus ab plus b equal to 41 as equation number 1 and a squared plus b squared equal to 61 as equation number 2. Let's focus on equation number 1. We are going to copy it down. A plus ab plus b is equal to 41. And we can manipulate the equation by adding both sides by 1. So our new equation is a plus ab plus b plus 1 is equal to 42. And let's focus on a plus ab. A is in common, so we put a outside the parenthesis, and then a over a is equal to 1 and ab over a is equal to b, plus b plus 1 is equal to 1 times b plus 1 is equal to 42. 1 plus b and b plus 1 are the same. So a times b plus 1 plus 1 times b plus 1 will become a plus 1 times b plus 1 is equal to 42. So our new equation number 1 is a plus 1 times b plus 1 is equal to 42. We can let it become our equation number 3. And let's list down the possible factors of 42. The factors of 42 are 1 and 42, 2 and 21, 3 and 14, and 6 and 7. So 1 and 42 can be a plus 1 and b plus 1 respectively. So a plus 1 is equal to 1 and b plus 1 is equal to 42. We can subtract both sides by 1 on both equations, so the value of a is equal to 0 and b is equal to 41. Let's focus on equation number 2, and we are going to copy it down. A squared plus b squared is equal to 61. And we will replace a with 0 and b with 41 to see if it's equal to 61. 0 squared is 0 and 41 squared is 1681. Is it equal to 61? It is not. So 1 and 42 as candidates of a plus 1 and b plus 1 respectively are not possible, because it will result to a false statement in equation number 2. Let's try 2 and 21. A plus 1 is equal to 2 and b plus 1 is equal to 21. We can subtract both sides by 1 on both equations, so the value of a is equal to 2 minus 1, which is 1, and the value of our b is 20. Let's replace a with 1 and b with 20. So the equation is 1 squared plus 20 squared is equal to 61. 1 squared is 1 and 20 squared is 400, and 401 is not equal to 61. So that will result to a false statement. Therefore, 2 and 21 are not candidates for a plus 1 and b plus 1 respectively. Let's try 3 and 14. So we can let a plus 1 equal to 3 and b plus 1 equal to 14. We can subtract both sides by 1 on both equations. So the value of a is equal to 2 and the value of b is 13. We can replace a with 2 and b with 13. Is it equal to 61? Let's check. 2 squared is 4 and 13 squared is 169. And 4 plus 169 or 173 is not equal to 61. It does not meet the criteria for equation number 2. What I meant is it will result in a false statement. So 3 and 14 as a plus 1 and b plus 1 respectively will be rejected. Let's try 6 and 7 as a plus 1 and b plus 1 respectively. A plus 1 is 6 and b plus 1 is 7. We can subtract both sides by 1 on both equations. So a is equal to 5 and b is equal to 6. We can replace a with 5 and b with 6. 5 squared plus 6 squared is 5 squared is 25 and 6 squared is 36. And 25 plus 36 is equal to 61, which is a true statement. So 6 and 7 as a plus 1 and b plus 1 respectively is valid. And since we have a plus 5, a is equal to 5 and b is equal to 6, we can now solve for a plus b. A is 5 and b is 6. And 5 plus 6 is 11. And that is our answer. Thanks for watching, and please don't forget to subscribe to my channel for more math content. Goodbye.